Let's start recording. Okay. Hi, everyone. Good afternoon, and welcome to today's Gifted World Masterclass. The session is titled, Are You Data Literate? Before we start the session, I just wanted to give you a brief introduction of what Gifted World is. I think you might all be familiar. We're a platform that started in January, and our goal is to enable students, teachers, and parents to reach their full potential through providing interesting, challenging things to do. Okay. One of the things we do is free master classes like this, but we also have online courses, which I will tell you more about later in the session. We're a couple of organizations that have spent a good amount of time in education came together to make this. And we are doing it online so that it's accessible to many of you. Uh, Before at the start, I just like to do a small poll where you could enter your details. So just FYI, this is a poll question that you all answered about. I asked you if my friend Ashwin is a quiet person. Do you think he's a librarian or a salesperson? And one Madhuvanti wanted to change her answer later to salesperson. So what we've got is 12 answers, 12 votes for librarian and one for salesperson. So now I'll just put another poll to capture your age. If you could just take the time to put out your age, where you're joining this call from, and your email ID. That'll help us get back to you with a couple of interesting videos and different resources that I'll be using during this class, or that will build upon things that I'm using in this class. Okay, so please take a little time to quickly fill this out. The 14 of you who have joined. Oh, nice. We're queuing. And because there isn't registration required for this, providing your email ID is helpful. Okay, there are still 5 people yet to fill in. Please do fill in. And you can share your personal email ID, right? Whatever email ID you want to get called on. And thank you for this short form reminder. Uh, People from previous master classes know that I get very confused by all the short forms that you're very used to. Good games. Okay, interesting. And no, just not an address, just a city, town, state. I don't need your address. I want to know, are you joining from Bangalore, Chennai, Dubai, Vishakhapatnam? Where? Right? Yes, and Viraj was the one who reminded me last time. Cool. So thank you everyone for filling out the form. I will end that poll now. So we've got, it looks like most people over here are age 11 and 12, which is great. A couple of you are younger, and only one person is above the age of 18. So welcome. Okay. So today's session is titled, Are You Data Literate? And to give you a bit of background onto why I'm doing this. So I'm a statistician. Okay, I have been practically using statistics in my day-to-day work for the last, I'd say, 12 years. Okay, and I've done it primarily in biology. Okay, so I'm an ecologist. I did a master's and a PhD where I was studying how plants in different parts of the world grow differently. And for that involved a lot of numbers, right? And a lot of crunching numbers. And I realized even when I was teaching undergraduates, okay, that the way we teach statistics is is very sort of convoluted and strange. Okay, and in the last year, since I've started working with Gifted World and GenWise and other organizations, I find that people in your age group, 9 to 12, are very, very curious, really want to know a lot about the world. And I think there are a lot of things that you can learn that normally would only be taught when you're a lot older, right? So this is a try at doing that, okay? So we're a small group of people, so feel free to drop questions in the chat anytime that you want, okay? And I will also open the floor to questions at any point of time that you want it, okay? So in today's class, we're going to be doing 4 kinds of things. First, we'll talk about some different ways that we can make statements about the world, okay? Then secondly, we'll do a bit of exploration of percentages, okay? And then we'll do 2 fun activities, one which is about correlations and the other one which is about medical tests, okay? Right? So to start off with, I want to ask all of you sorry, I already asked you that question. Right. So to start off with, we'll just talk about that librarian and salesperson thing that I asked you, right? I told you that my friend Ashwin is quiet and you feel like he's a librarian. So let's have 2 questions. One, how many libraries are there in your city? Just unmute and tell me your answer.
Probably a lot, maybe.
So give a ballpark. Do you think there are 10, 100,
About like
1,000?
about like 80
No.
to 100 or something.
80 to 100. Okay. Dhruva, which city are you in?
Dubai.
You're in Dubai. Okay. You think there
Yeah.
are 80 to 100 libraries in Dubai. So I think a good number of you are in Dubai. So let's just get your guesses of how many libraries are there in Dubai.
Around 20, 23, 25.
Okay. 25. So we just work with this. So there's one 80 to 100 estimate, 125 estimate.
Around 50 to 60, maybe.
32 something.
Okay, great. So now the second question. Okay. Uh, how many companies do you think are there that would want to sell you products that are there in Dubai?
I think every company would want to sell.
But number, give me number.
Maybe
100.
500, yeah, around hundreds.
Okay, so around hundreds. Okay. How many librarians does one library have?
About like
2 or 3
150 or
big,
something.
big librarians.
Huh?
Big libraries, maybe 3, 4, but then in small ones, maybe 1.
Okay. And how many sales people does an average company have, according to you?
About like 2000 or something.
2000 sounds like a rather big company. So what would a lower estimate be?
Maybe 30 to
10,000.
10 to 30.
Okay.
Sir, maybe 50, 30.
Okay. So let's go with 30. Let me just make sure I've checked the chat. Okay. So we're talking about, say, maximum 50 libraries, each having 1 to maybe 3 librarians. We're talking about 150 librarians in the city of Dubai. Okay. And on the other hand, with companies, we're saying maybe there are like 500 to 1,000 companies and maybe 30 salespeople per company. So that gives you about, say, 20,000 salespeople, right? I've just approximated it here. Okay, in case the multiplications were a little fast for you, don't worry. Okay. So now suppose what we've come to is that Dubai has about, what was our final number? We said 150 librarians, okay, and 20,000 salespeople. Now, knowing this information, do you think my friend Ashwin is a librarian or a salesperson?
Librarian.
Librarian.
Librarian?
Librarian probably.
Huh?
Librarian probably.
Okay, you still feel like he's a librarian. Manvik, would you like to tell us?
No, after seeing this information, we can see that there are 150 librarians and 20,000 salespersons.
Right.
So, such a drastic change. In the first question, we did not know the number of each. So we just assumed that there should be equal of both. So we probably said a librarian because librarians tend to be quieter. But now that there are so many more salespersons, there is a much higher probability that Ashwin is a salesperson because they can also be quiet sometimes.
Okay.
But the salesperson's job is to be opposite of quiet.
So, but I'm saying I know Ashwin only as my friend when I meet him. I don't meet him professionally. Maybe in his job he has to be very loud, but in his time back home he likes to be peaceful and quiet. I'm not one of those people, but anyway.
Well, I think he's a salesperson because he might be a manager and just sit back and relax while his employees do the work.
Great. And Virat says it can actually be both. Okay. So this is one of the things. This is called the base rate fallacy in statistics. You don't need to worry about that part. But this is a situation where the answer to this question really depends a lot on what background knowledge you have about the world. Just as Manvik said, when I gave you the question just as one sentence, it felt for you equally likely that he's a statistician, he's a librarian or he's a salesperson. But actually, when you look at the numbers of it, okay, there were, what did we say, 150 versus 50,000. There are 100 times as many salespeople as there are librarians. So if I picked a random person who was from that group of librarian and salespeople, I picked a random person. 99% of the time he's a salesperson only, not a librarian. Okay, only 1% of the time when you pick up someone like that, will they be a librarian. Okay. So that was just to close the circuit on that question. Whenever you're asked a question like this, you always need to think, right? How many of those people are actually there? If I was actually walking out into a crowd, they randomly bumped into someone, would they be a librarian or would they be a salesperson? Right? Would they be a biologist or would they be a computer science person? Because there are lots of computer science people around. Go ahead, Sanvi. You were saying something?
There would be like either scientists or like engineers and all. They are very common kind of.
Yeah. Yeah. Great. Lovely. So, okay. We'll get back to this a little later. Okay. What we've done just now has very big implications for how you look at the results of, say, your COVID test or any other kind of screening. Okay. And we'll come to that in a bit. But before that, I just wanted to ask, how many of you are comfortable with percentages? If you can raise your hand, are you comfortable with calculating percentages?
I'm comfortable.
Not comfortable. Wait, who said not comfortable?
I am comfortable with percentages.
I am.
Wait,
I
how
am.
do you raise your hand?
Okay, that's a good thing. Please try to raise your hand if you haven't already. So somewhere down there, there'll be one thing called react with a heart symbol. You press that and you'll have the option of raising your hand. So please raise your hand if you're comfortable. Yeah, Dhruva, I figured you figured out how to do the hearts, but also try and figure out how to raise your hand. Thank you. And it's totally okay if you're not comfortable doing percentages, right? Because maybe by age 9, 10, 11, you've not encountered percentages in life. Is that the case, Viha, Navya, Madhuvanti, Sanvi? Okay, Navya says she's Navya, you could just unmute and tell us how comfortable are you discussing with percentages or not?
It's kind of confusing actually.
It's kind of confusing actually. Okay. Viha, what about you? I can't hear you. You also find it difficult. Okay, cool. So we'll do a few small examples, okay? And we'll I'll walk you through them. So that way you also know that you can do it. What I'll do is I will post them in the chat. to make it easier for you. So we'll just solve a few examples. And I'll solve it with one of you in tow. Okay. So let me put everyone's hands down. Great. Okay. And Viha or someone who finds it confusing, let's work with one example now. Okay. Viha, would you be up for doing this example with me? Okay, great. So I've just put it in the chat. Ria had 200 rupees in her savings. She decided to buy a book for 140 rupees. So what percentage of her savings did she spend on the book? How would you go about calculating it? And it's okay to say that you don't know the answer. You don't know the answer. Okay. So the question, what percentage of savings did she spend on the book is same as asking how much of her total savings went into the book. Suppose she spent 100% of her savings on the book. How much would she have spent, Viha?
200. 200.
Okay, guys, when I'm asking one person, can we just give that person time to answer? And I'll come back to you later, okay? So Viha, you got that, right? If she spent 100, it would have been 200. She would have spent 200 rupees. Suppose I said she spent 50% of her savings on the book. How much would she have paid? 100, right? So 50 is half of 100. 50 by 100 is half. So that means 50% of 200 is 100. Okay. So this is just a matter of taking a fraction. Okay. So you can just write it down. If total amount you have is 200. Okay. And you've spent 140. So 140 over 200. And you can divide both those numbers by 2.
You get 70 out of 100, like.
Yeah, you can
And
divide.
then out of 100, percentage is basically whatever the percentage is out of 100. So 70 or 100 is the same thing as 70%.
Yes, thank you, Ayansh.
But this may not always be true.
Why not?
Because it can also be like, let's say 70.
What do you mean 70? As in?
The whole number could be 70.
The
Yeah.
whole number could be 70. Yes, that's correct.
Then in that case, you just divide by 7 and multiply by 10, whatever the number is. Like it's 3 out of 70, right?
Yeah.
I'll divide it by 7 and multiply by 10. So 3 divided by 7 into 10. Simple.
38.3. I will as a whole number then.
Okay. So I'm just going to interject into this and say that I know at your age, it's important to figure out how to do these calculations. I'm not saying that that's unimportant, but as you grow older, you can basically just do this with a calculator. Okay. Maybe for simple sums, it's good to be able to do things in your head. But very often on a daily basis, I keep encountering numbers. I need to come up with percentages and I just do it on a calculator. So what's important is that you know what it means, right? So how much of 200 is 140? 140 is 70% of 200. You calculate that by doing 140 divided by 200 into 100, and that is 70. Okay. So being able to do that is all that is necessary. You can do it with a calculator, you can do it by hand. But at the end of the day, you need to know what it means. Okay. So I'll just give you one more percentages problem. And then we can go to the next one. Okay. So the population of a town increased from 80,000 to 100,000. Okay. Can actually ignore the 1,000 and say it increased from 80 to 100. Okay. By what percentage did that population increase? I have one vote for 20.
So actually, I haven't done percentages, but according to if you minus 80 from 100, so it should be 20 only, right?
Okay. So that's why I gave this problem. Okay. By what percentage did it increase compared to the original population? Is what is sort of.
So 20%.
So what is 20% of 80?
20% of 80. So 20 should be. Yeah. No, wait.
It's okay. Take your time. Write it down. No worries. Okay. Now, for those who are finding that problem very easy, let me drop. So
is it 15?
16 actually, but close enough. Okay. So for those who found those first two problems easy, I'm dropping a tougher one over there, but I'm not interested in solving the tougher one in the class. You can solve it yourself here. Okay. So now to the 80 to 100 question. Okay. It increased from 80 to 100. I agree that 20 is 20%, like 20 is 20% of 100. But what is 20 over 80?
20 over 80.
Like the fraction 20 divided by 80.
20 divided by 80. It should be. So 4. So it should be kind of 1/4.
1/4, right?
Yeah.
And 1/4 in percentage is 25%.
Yeah.
Right. So when you talk about something increasing, the population of this town increased from 80 to 100. Compared to the original population, the 20 that it increased was 25% of the original population.
Yes. So now it is 20% of
Yes.
the entire population. Okay.
Yeah. Right. So that was the increase last year, was 25% of last year's population.
Yeah.
But the new population
It's
is only
20%.
20% of the current population.
Yeah.
Right. So
Yes.
you see that difference. Okay.
So it increased by 20%, right?
It increased by 25%.
25%. Okay.
So compared to the old population, so the amount of added new people is 20.
Yeah.
Compared to the old population, 20 is 25%.
5%. Also 25% more.
25% more.
More.
Compared to the new population of 100, 20 is 20% only.
Okay. So.
Right. So always when you say something increased, something decreased, you're referring to what it was before, not what it is now.
Okay.
How much did it change to get to what it is now? And for those who solved the bigger problem, the the pricing problem that I shared, the correct answer is 10,800. Okay. And yeah, great. So that way you can keep happy with that. So I wanted to do these 2-3 percentage problems just that you have an idea of what percentages are like. There's another really fun way to interact with percentages, which is, okay. And this we're just trying it out for fun, okay? I have over here a metronome. So what it does is it just plays sounds like this, okay? Can you hear the beat that's coming here?
No, sir.
You,
not much.
you can't hear a tuck, 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 tuck sound? Tuck.
No.
Not able to hear it? Okay, fine. Then Zoom
No,
is
sir.
just, yeah, okay. Zoom is just trying to only catch voice and doing things. So I will, there.
It is basically a beat that repeats after certain intervals of time.
You hear it? Sorry.
We can't hear it.
You can't hear a beat here.
No.
Okay, we will skip that plan. Excellent. So no worries about it. I'll just jump to the next segment. Okay. So where's my plan? Sorry, just a moment. I needed to check that. Okay. So now we'll just jump into the next section. Okay. Which is, what are the kinds of questions? Before I go there, sorry. What do you think statistics is? Feel free to unmute and tell.
Bar graph.
Come to a class that's supposedly about statistics, but what do you think statistics is about?
I think statistics
Data handling
is
related.
I think statistic is when you take data and organize it in different ways. And
Sir, like,
Okay, wait, one at a time. So I heard Manvik and then Sanvi and then Viraj. So go Manvik. So you said you take data and you organize it.
yes, you have graphs and all for statistics, and in statistics you can also yes, you measure how much data is there. You can you suppose if we also had that problem, we have to calculate stuff. You have to that also maybe comes under statistics.
Okay, great. Thanks,
Percentages
Manvik.
and
Thanks, Manvik. So we'll just collect a few points from everyone so that everyone can speak. Okay, so let's just be brief in what we want to say. Sanvi, what do you think statistics is?
Sir, I think it has to do something with data handling, how we arrange the data and information we get.
Okay, how we arrange information we get, how we
Yeah.
interpret information that we get. Shan?
Yeah, so statistics is like basically and like first collecting, analyzing, then processing data.
Okay, great. And Viraj, finally?
sir, it's basically like you're collecting the data and storing it with you in an organized manner.
Okay, so what I heard a lot is about collecting data, collecting, storing, organizing in different ways. But actually, from my point of view, statistics is about how do you ask and answer questions. Okay, that's basically what it comes down to. How do you ask and answer questions about the world? Okay, so to start off with, I am going to share with you 3 different kinds of statements that we can make about the world. Okay, and I'll just use the chat to share this with you, since I really love how active you all are in it, right? So there are some statements you can make about the world that don't involve numbers, right? The sun rises in the east, water is needed for all living things, plants need sunlight to grow, things like that. Right? There are no numbers involved in any of those statements I said. Okay. Some statements about the world become a lot clearer if you have numbers in them. Okay. So again, I've given you examples over there of here are some statements that are, when you say it just in words, it's not as clear. The earth is much older than humans. Okay. When I say it with numbers, the earth has been around for 4.5 billion years. Okay. 5 followed by 8 zeros. Whereas humans have only been around for 200,000 years. Very, very tiny time. Okay. So I could say that my grandmother is much older than me. Right? My grandmother is much older than me. But she's only like maybe 3, maybe 5 times my age. Here, the earth is like at least 1,000 times older than humans. That's very, very different. Right? So those numbers give you a clearer idea when you make that statement. Okay. And finally, there's a third kind of statement that we can make, okay, where the answer is not a very clear number. Okay, all these statements that I've stayed over here as example, the age of the earth, the age of how long humans have been around, populations of different countries, areas of different countries, those are things that you feel sure have a definite answer. It might be difficult to find that definite answer, but you're sure there is a definite answer.
So what did you say was the meaning of statistics by your opinion again?
According to me, statistics is about asking and answering questions. Okay. And why exactly, it'll become more clear to you as I share these three kinds of statements. Okay. So we've discussed first statements that just words don't involve numbers. Second, statements where numbers are helpful. And thirdly, the third example I'm going to put in over here is what I'm calling as statistical statements. Okay. Questions like, how many hours do you spend on homework each week? Okay. That's a question that doesn't have a single correct answer. Each week it changes for each of you. If you look at your whole class, that number is very different. So the answer to the question of how many hours do you spend on homework in a week is a spread of different answers. Am I right? Like, does that make sense? I think I made a mistake by sending you like too many questions off in one go. So actually, let me.
No, sir, it makes sense.
Yeah, no, what I'm going to do is just send one question at a time. I made a mistake of copying the full thing in. Okay, so let's just deal with the question of how many hours do you spend on homework each week? Right? So unlike the previous example where I was talking about the age of the Earth has a definite answer. I might not know it, but it's definite. Right? How many hours you spend on homework each week is a whole bunch of different numbers. It's not a single answer. Okay. How much time does the light rays take to reach the Earth from the sun over the years? Again, is not a single answer because the distance of the Earth from the sun is not constant. Right? The Earth is moving in an oval around the sun. So when we're closer, the light is coming faster. When we're further away, the light has more distance to travel. So that's also this kind of a question answer. So this last set of questions where the answer is not a single number, but a bunch of different numbers, those are the questions where we're using statistics to answer them. It is how do you look at these statements that have many possible numbers, and let's come up with some kind of way of measuring it. Okay. So now for simple, we'll just stick with this example. I want all of you to type in the chat, okay, how many hours you spend doing homework each week. Okay, just for this week. Today's Sunday, no? This week is over. Just think about it. How many hours did you spend doing homework? And just give me a plain number. Or wait, actually, I'm going to make my life easier here. No, okay, yeah. So let's see what comes in the chat. I see 13 to 6, 18. Wait, hold on. Okay, if someone could help me by reading out the numbers in a line.
Sir, I could.
Sir, I could.
Go ahead.
1, 14.
So it started with 13. So it started with 13 from Vihan.
13, 18, 6, then 14, again then 3, 4, 18, 5, 15, 19, 16, 10 to 15, 6, 2, 8 to 9, 14, 1, 16, 18, 4, 13 to 15.
Wait, I think that's enough because we've already hit 16 people and there are only that many people in this meeting. Oh, wait, there are 22 people in this meeting. Sorry, please continue.
18, 4, 3 to 50, 13 to 15, and 11.
Okay, great. So now we've just evenly got about 20 numbers. Okay. Let me share my screen. Okay. And I'm not doing anything too fancy over here. You can see
Sir,
all.
actually 21, including me.
It's okay, 21. But it's fine. I'm going with 20 numbers because 20 is easier to think about. Okay. 20 is a nice round number. 21 only divisible by 7 and 3. Okay. So I might have missed some of your answers. It actually doesn't matter. It doesn't matter for the purposes of this. So these are all the answers that you gave. Wow, someone spent only 1 hour. Good for you. Someone also spent only 2 hours. Good for you. But also no harm in case you spent 18, 19 hours. That's just how life is in terms of how your school is. So how do we make sense of this whole bunch of numbers that come to us? Anyone has ideas about how can we make sense? Because there are 20 numbers on the screen. Now,
Sir, we can
answer this question?
In a graph.
Sir, we can put them in like a table in which will show how many students studied in 30 from 13 hours, how many students studied in 18 hours, how many students studied 6, 2, 1.
Okay. Anyone else?
Put it in a census graph.
Okay, so the first thing that makes sense to do is to sort it. Okay, put it in increasing order. Right? And now I can look at this. Look at these numbers.
You could also find the average of these
I
numbers.
can find the average. Okay. And on a computer, that's actually very easy. Right? On a computer, it's very easy. So let's not worry about exactly how you calculate an average. A2 to A21. And we discover that among your group, the average, which is if we take up we add up all these numbers and we divide it by 20, we find that average to be 11.5 hours of work. Okay. So the average does describe it, but the point is I can actually get an average of 11.5 by having this set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over here, 12. Okay. So the average of this set is also 11.5. So now we've got two groups of numbers. The average of the first group of number is 11.5. Average of second group of number is also 11.5. But they're very different groups of numbers. You can see that, right? Okay. So the average just tells me roughly where the middle is. It doesn't tell me how spread out it is. Okay. So when you're comparing two groups of numbers, there are two ways to describe it. Okay. One is describe where the middle is, then also describe what the spread is. Okay. One way of describing spread is to say the least number in this is 1 and the biggest number is 19. So in this class, in this group of 21 people, the amount of time you spent on homework last week ranges from 1 to 19 with an average of 11.5. Okay. Whereas in this group, it ranges from 11 to 12 with an average of 11.5. I give that information, you know, those are different. Okay. So statistics would give you ways to then tell, is this actually different from each other? Are these groups different from each other? Suppose I looked in your school at different sections, okay? And I asked the same question. How many hours are you spending on homework? Suppose this is class 5 and we look at section A, B, C. And section A spends on average 3 hours. Section B spends on average 9 hours. Section C spends on average 13 hours. This is concerning, right? Your school sections shouldn't be spending such different amounts of time doing homework. So
But it may vary from the timetable.
You're saying, but
Like
don't different sections have very different timetables over a week?
Oh, yeah, right. That is also a point.
Right? So over a day, it makes sense that maybe your classes were different over a day, but over a week, you have all the same classes, right?
Yes.
What have we been doing here? We've been doing statistics. We've asked a question. We've collected numbers for the answer. We've combined the numbers into a way that we can analyze it. Okay. And often, one of the things that you mentioned, often we make pictures out of it because pictures are easy to understand. Okay. Now, in today's class, we have about 15 minutes more of the plan. Yeah, so there's been a discussion about range. There are other ways of showing spread. Okay. What we've discussed just now is how do we compare two groups of numbers? Right? We made two groups of numbers and we compared them. We compare them by looking at the center of the group and looking at the spread of the group. Okay. So in the example below, both had the same center, but the first one had a much bigger spread and the second one had a smaller spread. Okay. It's possible that the centers are different, the spreads are different, and there are different ways to calculate and ask the question, is one group bigger than the other? Okay. That's one kind of statistical question. The second kind of statistical question that I'm interested in, and I will share my screen to show you, is to ask if one quantity changes, the presence of one quantity changes another quantity. Are two quantities related? Okay. So for example, I'll give you a very simple situation. Okay. Very simple situation. I hit you. Okay. And your cheek hurts. Okay. Is there a relation between those two things, the amount of pain you're feeling and what I did? Yes, no, very direct relation. I hit myself, right? I hit myself and my cheek hurts. It's very clear that hitting leads to cheek hurting.
So that's cause and effect.
That's a causal effect, right? There is cause. Hitting causes cheek to hurt. Not eating causes me to be tired. Okay.
Yes.
Eating too much food causes me to feel sleepy.
Yes.
Yeah.
Okay. The sun rises in the east. Is there a statement of cause over there?
No.
No.
No, not really. Okay.
It's like a fact.
It's just like a fact. Okay. So now let me just share. Okay. So this is a really lovely website called Gapminder. It might be a little too complex for you. Okay. But you can definitely visualize it. The website is just gapminder.org. And it's a bunch of economists who pulled together a lot of really great numbers about how the world is progressing, for example. So over here, I have chosen to graph. Okay. So this is a graph where the vertical axis or the y-axis. Now, if you're seeing a graph for the first time and you don't understand what these things mean, that's part of the point of this class and the course. Okay. The numbers over here represent, on average, in a country, how many babies are born per woman in that country in the year 2023. Okay. And on the x-axis, it's the average daily income per dollar, like in dollar per person per day. Okay. So each dot is a single country. So you can see in Zimbabwe, there are 3.72 babies per woman and an average daily income of $4.46. Okay. And if you look at this graph, what relationship are you seeing between the two things that we're looking at? Anyone?
So there is no relation. I think we are just comparing. Like, are there more babies in the country, or is there like more income generating?
So you're saying there's no relation between babies per woman and income?
Sir,
Yeah.
there is if there are more people in a family, then you might want to buy more products for that family.
Okay.
And
But,
people
wait, sorry, wait, because I can't see your faces. Let me add faces. Wait, who was saying more people in the family want to buy more products for the family? Madhuvanti.
It's me, Madhu. Yeah.
Okay, excellent. Now, what is this graph showing you? If there are more people in the family, that means you're up here. Right?
Yeah.
This, you're vertically should be higher.
Reason.
Right? And you're vertically, in the vertical, you're higher. But those points are where? When the number of babies per woman is high, is the average income high or low?
Low.
Higher.
Now it's about
Higher.
Low.
It
Right?
would
So
be
it's the
higher.
opposite of what you said, Madhuvanti. When there are more people, the average daily income is lower, actually. Vihan, you had, sorry, Vrishan, you have your hand raised.
Yeah, I just wanted to say that the more the babies per woman are there, the less income is there.
Right, right. So what we're seeing over here, the pattern that we're seeing, okay, is that the less the daily income, the more babies per woman, or the opposite, the way Vrishan phrased it. The more babies per woman, the less the daily income. Okay. So this brings us to a second important thing about statistics, right? Earlier, I had told you it's about asking and answering questions, but an important thing to separate out when doing statistics is we distinguish between patterns. Over here, we're seeing a pattern and a process, which is a cause. Okay. And I'll give you example. So this is one example. So let me ask you, what might be a cause for this? Can you see that is there possibly some reason behind this graph? Anyone?
So this is only showing data. We may not know the reason.
Okay,
Because
but
this
can
is-
you think of a reason?
Sir, because there are more people and people need to buy more products if there are more people and all of that.
Mm-hmm.
Sir, because there are more families, more people per family, they tell the manufacturers to manufacture more products.
Okay. So, but note that each circle over here is a country. So Sweden, for example, makes $60 per day, and there are only 1.4 babies per woman in Sweden. Versus in Yemen, there are 5 babies per woman and they make only $2 per day. Is it possible that as people get more educated, they have a higher standard of living, they have fewer children? So actually, this is instead of that, it's better to compare it to
So actually, I thought you were talking about the daily income of the business people.
no, average daily income of everyone in the country.
Okay.
That's a nationwide average daily income. So for example, this is instead of babies per woman. Yeah. So over there, I was saying a potential cause is that as women get more educated, they choose to have fewer children. Okay, and you can kind of, maybe not really, that's over here, the number of school girls who complete primary school, is it related to number of babies per woman? So that's an aside, we'll get to that later. But one fun thing about this Gapminder website is you can keep trying different things, right? And see how different countries in the world are shaped in different ways. For example, this one shows what I've changed on the y-axis, the vertical axis, is the GDP per capita. So it's roughly how wealthy this country is. The
Sir,
higher
what's
is,
this? Sir, what's this application's name?
it's called Gapminder. Gapminder. You can see it up here. Okay. So in Gapminder here, for example, is showing that as a country gets richer, more people are completing primary school, except for Nepal, which is not very rich, but lots of people are completing primary school. Right? Can you see that roughly over here, there's a line? Right? Can you guys see that line?
Yes.
Yeah. So Niger, for example, is not very rich, and very few girls are completing primary school. Whereas you go up as they get richer, more and more girls complete primary school. But here are some other correlations. Okay. What are you seeing? So this graph has two lines on it. Okay, I'm going to make it bigger. Okay, this graph has two lines on it. The red line shows the number of pirate attacks that have happened in each year globally. The dotted black line shows how much percentage of email is spam. Do you guys know what spam is?
Yes.
Sir, obviously I know it's like again and again doing something.
Okay, random nonsense emails. Okay, spam. So how much of email is nonsense versus how many pirate attacks have been there in the world? And see over here, such a strong relationship. No? Over
Yes, so
time,
all of them are going there. Both of them, they are decreasing year by year.
Yeah, so do you think they're related?
Yes, sir.
Why? So give me a reason why you think they're related.
Because it's basically showing how the world gets safer each year.
That's a good point. Okay. The world is getting safer each year. So what you're saying is that maybe there isn't a direct connection. It's not like pirates are sending spam emails, right? It's not a direct connection, but there's some third thing. The world is getting safer. That third thing is causing both email spam rates to go down and pirate attacks to go down. Okay, here's another one. Sorry, again, let me make it bigger. This is showing that since 1989, the number of lawyers in the United States very strongly correlates with the average milk produced per cow in the United States. Does anyone think it's related? Like do you think that there's a cause that is connecting the two?
No, sir, I don't think it's not at all connected. Only the
Maybe there are
increase
more
every
lawyers.
year.
Maybe if there are more lawyers, more people drink milk.
No. I'm saying since there may be more lawyers, they may be like for like more like.
No, actually, it's because each year the population of the world goes higher, and hence they need more lawyers and more milk to supply that population.
But why should the milk produced per cow increase? Maybe you just have more cows. This is saying that each cow is making more milk.
Maybe because like they've been treated better.
Okay, so this comes to a very important point. And I know I said I won't use slides, but I'm still. And this is actually is not. Okay. So this is like a very, very important principle in statistics. If you're having an introduction to it in middle school, this will be drilled into your head. If you're having this in undergraduate, it will be drilled into your head. If you're doing PhD also, it will be drilled into your head. because people don't, this is not how our brains function. Okay, it's very counterintuitive. For us, for regular people, if we see a pattern out in the world, we think that there is some process that is causing the pattern. Okay. So we saw a pattern over here, that these are two numbers that have been increasing in time, and we came up with a reason. We tried to come up with a process underlying it. Okay. And until you show the relationship between things in a strong manner, you can't say that this correlation just means two things are changing together, means that there is some underlying cause. In fact, both of these graphs I got from a lovely website called Spurious Correlations. Okay. Where
Sir, that's not the website. The website is tylervision.com.
Yeah. But you search for spurious correlations and you'll find it. Okay. So Tyler Vision is a statistician who's made this. And he's got a whole bunch of crazy things, right? So yeah, master's degrees awarded in parks and recreation and Google's stock price. You can see it's so well correlated. Okay. So there are many situations in life where there will be a pattern, and we're very tempted to sort of say, hey, there's some reason for that pattern. But often it just is that, oh, here are two things that were increasing. Here are two things that were decreasing. And we happen to put them together. Okay. Importantly, lots of people will try to sell you fake news, different kinds of products, general nonsense by doing this. Okay. There will be lots of, you'll find it across in life that lots of people will say, hey, this happened, that also happened, therefore they're related. And therefore, they'll try to either market something to you or feed you false information. So you need to remember that two things can always be correlated with each other without having any underlying cause. Right? So for example, this is the number of art directors in Arkansas, a state in the US, and the yearly peak of the New York Stock Exchange.
Sir,
Yes, go ahead, Navya.
so it's like coincidences and our brain is just tricking us into making a reason.
Yes, that is a much better word. Coincidences. Right? You all know that coincidences can just happen. And there are tools within statistics to measure this. Okay, to measure coincidences that just happen.
Okay.
Okay. So I think I have run into the time limit that I had set for this part of the session. So I'm not going to do the final medical tests part that I'd planned, which is fine. So all of this that I've just done is sort of a part of a full course that we're offering on Gifted World that starts 2 weeks from now. Okay, I will just share my screen so that I can show you more about it. I'll just give you a brief about what is the upcoming course, and then we can break to answer questions. Okay. So some of you might already be signed up for this course. I think you can raise your hands actually if you're already signed up for this course and joined from an email that told you so. Okay, great. Yeah, nice to see so many of you will be joining the course. Then it also means that I can't reuse this material now. So it's okay. Making me do more work is not a bad thing. Okay, great. So about 6 of you are already in this course, and you're going to make my life difficult by making me have to create new material, but that's fine. And we created these courses because for a long time, we've heard a lot of parents tell us that their child who's good at something is not feeling challenged enough in class. Okay. I also had that problem when I was in school. And the answer to it is to find ways to teach you how to challenge yourself. Okay, that's my goal overall, and that's our goal overall with these courses. We've created a bunch of online courses where the goal is to teach you how to learn by yourself. Okay. Starting in September 14th, there's one which is called Junior Detectives. As I told you, statistics is about asking and answering questions. So we're going to frame it like your detectives doing investigations. Okay. This is a junior level course, and then there's a senior level course on data insights and visualization. So it's for the older grades that will be taught by Ashish Kulkarni. Then who's an economist, and he's the person who showed me Gapminder, and which is why I like using it. Then we also have a course on storytelling and another on financial literacy. For both storytelling and financial literacy, in the upcoming week, there are free master classes like this one, which will be done by the mentors of those courses. And we've just finished a bunch of courses, one on scientific inquiry, one on harnessing Gen AI, another on pre-algebra for your age group, and another on economics. So these courses are structured in a way that each week it will start off with you getting a package of materials to learn. Okay, we'll send you some things to learn at the start of the week. Then there'll be an assignment that you'll do. While you're doing the assignment, there'll be a session where you interact with a teaching assistant. So in addition to me, there will be a teaching assistant in the course. Her name is Arya, and she's a master's student in biology. So once a week, you'll get to interact with Arya and ask her your questions. That's before you submit the week's assignment. Then at the end of the week, we'll meet and we'll discuss your questions from the assignment.
Okay, sir.
The goal of doing it this way is it's not that I'm giving you a class and then you're solving homework. You do homework first, then we do class. Okay? Because the goal at the end of the day, the way that you will really become empowered as a learner is if you can learn yourself. Okay? And that's why we're doing this in Gifted, why we're running it in Gifted World, because for a long time we've been running programs for students, and we're able to engage curiosity. We've got a lot of really lovely mentors, but the question was, how do we enable you to learn for yourself? And that's why we created these courses, right? I'll drop an email to all of you who attended and share with you if you haven't signed up for the course yet, I'll share with you a coupon code that you can share with your parents. It will enable you to sign up for the course at 20% off. Thank you for attending this masterclass. But apart from that, now just open for questions, and I'm available for the next 20 minutes, and we can answer questions about statistics about this class. We can also do other fun activities, whatever you're up to. So the next 20 minutes is for you to trouble me as much as you want. Who wants to go first?
Sir, how do we use statistics in real life?
We'll get to that. Okay, to give a bit of an answer, you use it by learning and doing. It's not the kind of topic that you can just sit and learn the theory of. You have to actively do investigations. For example, during my undergraduate, 5 years of combined bachelor's masters, I must have attended like some 3-4 courses on statistics. Okay. So a course means that I'm putting in, say, 40 hours of work onto that. So if I attended 3 or 4 courses, I put about 150 hours of work into statistics. I did not learn statistics that way. Okay, I put 150 hours of work into statistics during my bachelor's and master's, and I did not learn it that way. I learned it after I spent 4 months sitting and collecting and measuring grasses and counting plants and doing all kinds of things in the Himalayas. I came back and I had to analyze and say, what did I find out? Then I learned statistics.
And sir, is it always true that correlation is not causation?
No, not at all. So all it says is that correlation is not necessarily equal to causation. There are many situations where you find two factors that are very well correlated, and there is an underlying cause for it, right? But the actual, so when I saying correlation is not causation is a contraction. The full statement is correlation is not necessarily causation. So just finding a correlation doesn't necessarily mean that those two things are linked. It just means, oh, it's happening, right? So for example, in that spurious correlations website, you can find that, I found that one. Where was it? I didn't save it. Wait, there was a really nice one about the distance between Jupiter and Mars and some stock price. It correlated beautifully. The distance between the planet Jupiter and the planet Mars and the price of that stock during that year. Okay. But what is the relationship between where Jupiter is and where Mars is and where that stock price is? Right?
Maybe that stock price is from Jupiter or Mars.
No, it's from the Earth itself. Okay. So anyway, Vrishan, you had a question?
No, I didn't have a question.
Okay.
Actually, I had a question.
Yes.
Is there any relationship between percentages and statistics?
So percentages is just a basic way of sort of dealing with the world, right? Describing numbers in the world. And if you remember, I took you through that progression of statements without words, the sunrise without numbers, the sun rises in the east, for example. Then we next progress to statements that have numbers in them. And finally, we progress to statistical statements. So we tend to use percentages a lot. You'll see news items saying that, I don't know, smoking increases your chances of lung cancer by 30%. What does that mean? Don't know, right? Actually, if you're all okay with it, I know people have been leaving, but I'll take you very quickly through a common fallacy. The librarian salesperson thing that we did, right? Okay. I can do an advanced version of it if that's helpful.
Sir, I found this on Google. I don't know how does this relate, but it's saying that chances of chances of a person getting cancer and chances of Japan hitting an earthquake. How does this make sense?
So that's the point of spurious correlations. They don't make sense.
Sir, also like the thing that you were gonna explain, like
Yes, Shan.
it's like very common actually. Like for example, the weather. In the weather forecast, sometimes it says like 30% chance of rain in, let's say, Dubai.
Right.
But that actually means that 30% of the land in Dubai will get rain, and not that there's.
Sure. Weather prediction is a science that is deeply statistical. In that, lots of statistics gets used, and it's also very uncertain. So this is something that I'll bring up in the course, but it's about 10 years ago, a person I really, really admire defined science using one sentence. Okay, and I'm going to write that sentence in the chat. Chat. Okay. He said, okay, and it's in all caps, apologies. Science is an enterprise that begins with humility and ends with uncertainty. Maybe there are spelling mistakes, but who cares? Science is an enterprise that begins with humility and ends with uncertainty. Okay. I love this statement. Okay. It says that science begins with being humble and saying, I don't know. That's what causes you to ask a question. No, you don't know the answer. If you know the answer, why you'll ask the question? Okay. And it ends with uncertainty, which is that the answers you find are not always 100%. This is exactly why it happened. Same with the weather. You get an answer saying 30% rain. Okay. You get an answer that says 30% rain. And that's uncertain. I'm not sure. Usually, okay, when you get any answer out of a scientific process, out of a statistical question, the answer is also a spread. Like our input data was a spread of the number of hours you spent doing homework, with a middle at 11.5 and ranging from 1 to 19. Usually, when you say the chance of rain today, you'll say the chance is 30, that middle is 30, but it could be anywhere between 0 and 60. Or the amount of rainfall that you expect to fall today is 20 millimeters with a range of 10 to 50 millimeters. So statistical answers always have a middle and a range.
Sir, I found another one which actually kind of makes sense. Centimeters of rain in Mahabaleshwar and centimeters of snow in Kashmir. It actually makes kind of sense.
Potentially, but again, you'd have to show a cause. It's entirely possible that the rain in Mahabaleshwar is not driven by the monsoons. Or, yeah, and Jammu Kashmir, adjacent to Jammu Kashmir is Ladakh. Adjacent to Ladakh is Spiti, where I have spent a year doing my master's. That's an area where the rain doesn't come from the monsoons. So if you look at centimeters of snow in Spiti, it's not correlated to a monsoonal system. Now, if you're able to show a system that is a reason that is causing both the things that you found, then that's valuable. Okay, and it's actually a very, very complex subject. Economists, all kinds of scientists are really having a very complex time of trying to figure out how do you show that X causes Y, or when you put X and Y, whatever you want.
And sir, I found another one. This is
Wait,
saying
Viraj, just a moment. We'll just see if others have any questions.
Okay,
I know it's a lot of fun going through these spurious correlations, which is why I will send you the website along with other descriptions of the salesperson librarian thing. And I'll also send you the website of Gapminder so that you can all explore on your own time. Anyone else has questions?
So I found a very funny correlation.
Okay.
Google searches for I'm not even mad correlates with popularity of the whip name meme.
Yeah.
Sir, I've got a funnier one. Sour cream consumption versus visits to Disneyland.
Right. So you're going to keep finding these things. And the reason this website is called spurious correlations for a reason. There's no reason to expect that these things are related. Okay. So if we, anything else? Any other questions that are not related to spurious correlations now? Okay. Enough spurious correlations conversation.
Sir, how much time do you think will take any one of us to learn statistics?
I'm still learning. So, I mean, if it's something that you care about, you're going to spend time learning it. So don't worry about it. It's related to a lot of skills. In fact, this librarian salesperson thing that you did is related to one of the more complex ways of looking at statistics, in that you need to have a lot of prior knowledge, but in fact, the most correct way of looking at it. Okay, but we're not going to get into that even during this course, because It's something that you can't teach at a... And when I say can't teach, it means you don't have the tools really to work on it. Certainly into high school. Like I think you have to learn a bunch of stuff that traditionally is only taught in 10th, 11th, 12th grade by the time you're able to get into Bayesian statistics. But don't worry about that. There's still plenty of things we can figure out about the world. Okay, and since you're all still interested and we have 10 more minutes of time, I'm going to drop one more interesting nugget that you can figure out how to do over time, okay? Again, I'm going to use the chat to write this down, okay? Suppose I have a test. Suppose there is a medical test for, I don't know, can someone name some rare disease? Or some rare virus?
Sir, like you mean rare or fatal?
Okay, fatal but rare virus.
The Black Death.
No, but that's not fatal anymore. Now, today.
Monkeypox.
Monkeypox, okay. Okay, that is 99% accurate. Okay, I'll actually, let me just write it. I'll share a sheet with you and then we can do it on the sheet. Okay, so suppose there is a test for monkeypox. Okay, that is 99% accurate. Okay, so test for monkeypox is 99% accurate. What does this mean? Okay, this means that if you have monkeypox, 99% of the time the test will correctly detect that you have monkeypox. 1% of the time it will go wrong. Okay. Now suppose you have 100,000 people. Okay. And we know that only 100 people have monkeypox. Okay, on average. What this means is that 1 in 1,000 people have monkeypox. We know that monkeypox is relatively rare. Okay. Now you test everyone. You test all the 100,000 people. Okay. Now this test is 99% accurate. That means 1% of the times the test is wrong.
That means the entire people which have monkeypox will be ignored, and the entire people which have monkeypox will be noticed, which don't have.
No. So okay, so we test everyone. We'll get there, Viraj. You're partially right. Okay. We test everyone. 1,000 people will be diagnosed as having monkeypox wrongly from that 1% inaccuracy, because you're testing 100,000 people, right? 1,000 people will come as being diagnosed as having monkeypox. Of the 100 people who do have monkeypox, most of them, 99% of the time, their test will come correct. Right? So of these 100 people, 99 will get positive test. 1 will get negative test. Do you see this? Do you see why this is the case? Because we said 99% accurate. So these 100 people who have monkeypox, 99 will get positive test, 1 will get negative test. For the remaining 100,000 minus 100, 99,900 people, roughly 1,000 people will get diagnosed as having monkeypox who don't have it. So now suppose you don't know whether you have monkeypox or not. You don't know whether you're one of those 100. But you get a positive test for monkeypox. What is the chance that you actually have monkeypox? Anyone?
So 99% chance you have?
Okay, based on that first statement, you think that if you get a positive test, there's a 99% chance. Okay.
Sir, I did not understand the question. Can you say it like this?
Actually,
Elaborate.
it could be 50-50 also.
Okay. So okay. You get a positive test. Okay. So I'll repeat. We 100,000 people. We test all of them for monkeypox. Test is 99% accurate. Okay. But that means 1% of the time the test makes mistake. If you test someone we know 100 people have monkeypox.
So 10%. 10% we have monkeypox.
No, 10? Yeah. There's a you've got a 10 at the end of this, you have a 10% chance that you have monkeypox. But we'll get there. Okay. So when you test all 100,000 people, because the test 1% of the time it gets it wrong. So roughly 1,000 people who don't have monkeypox the test will answer and show positive for them, because 1% of the time it's gone wrong. Okay. So now your chance of having monkeypox, if the test is positive, is what is 99 divided by 1,000 plus 99 and into 100 to give you roughly 9%. So 10%. Now this was very prevalent during COVID when the pandemic was going on, because everyone was getting tested. Suppose the amount of COVID, the number of people who have COVID is very low. At that point of time, there will be lots of tests that will come just because of that 1% inaccuracy. Because of that 1% inaccuracy, lots of people who don't have COVID will test as positive. Which is why what were people telling you to, what were doctors telling you to do when you got COVID in terms of testing? Does anyone remember?
Yeah, quarantine yourself like 14 days.
But only if you got one positive test.
No, then I think recheck, retest.
They retest for this reason. Right? Suppose there is very little monkeypox or very little COVID in the population. Before testing, okay? Before testing, 100 by 100,000 people have monkeypox. So before you test anyone, all you know is that 0.1% of people have monkeypox. This is the same as the librarian salesperson thing we were talking about. Okay. We said we don't know anything about Ashwin. But I know there are 100 times more more salespeople than there are librarians. So without any additional information, I expect Ashwin to be a salesperson. Now I know that Ashwin is quiet. Maybe that increases the chance that he is a librarian and not a salesperson. Because I know more librarians are quiet than salespeople, but not by a lot. Okay. This is a difficult thing to figure out with librarians and salespeople, easier to think about with a medical test. So before testing, I had a 0.1% chance of having the monkeypox. After testing, I have roughly a 10% chance of having monkeypox. For 10% chance, will you go and quarantine yourself for 14 days? No, right? Which is why you do a second test. Now, when you do the second test, that increases. If the second test also comes positive, Now that really shows that, oh, you have the disease. Okay. Because now you again put that 99% accuracy on top. I'll send a video that might be a little high level for you, but if you're able to understand it, it'll be helpful because it uses a lot of pictures. Okay. I'd say what you should take away from this is that while tests can be very accurate, the actual chance that you have that disease or not depends on how prevalent it is in the population at the same time. Just like this librarian and salesperson, the chance that Ashwin is a salesperson is far more than that he's a librarian, because there are far more salespeople in the world than there are librarians. Okay.
And sir, it's actually hard to find out if they have any disease or not, because there could be like only one cell is infected with that disease.
But that is brought up in the accuracy of the test. Right? That accuracy says that if you have it, I'm going to detect it correctly 99% of the time. So maybe that's a very powerful test. Right? So that accuracy of the test is already taking what you said into factor. But what I showed you is just when you're dealing with a large number of people, if you have a 99% accurate test, still not enough. That a single test tells you whether you have it or not. If you do 2 tests, then there's a pretty good chance that you have it, which is why during COVID, they were always asking you to recheck after you got a positive test. However, when during the peak of the wave, in the initial times, they weren't asking for rechecks as much. They were asking for rechecks. In the peak, because I got COVID in January 2022, which was a peak of a wave in India. And at that point of time, nobody was asking for retests. They're like, you got a positive test, you got it. You please isolate yourself. Okay. So, but anyway, the math for this might be a little advanced. Don't worry. But you got the rough idea with the librarians and salespeople thing. Cool. Thank you all for coming today. This was a lot of fun. I hope you also enjoyed it. Feel free to give any feedback that you have. And for those of you who sign up for the course, I'm looking forward to interacting more with you over the coming weeks. And tell your friends, in case you like it, they'll probably also like it. And I'd love to hang out with more of you on a weekly basis. We also have other upcoming masterclasses, so stay engaged on Gifted World, and we'll be in touch. We can now's a good time to just unmute and say bye. And anything else you'd like to share?
Bye.
Bye, Anand. Thank you for coming.
Bye.
Bye, sir.
Thank you.
Bye-bye.
Bye.
See you around.